Okay, so this is how you will do the lactate dehydrogenase reaction. You're going to have a spectrophotometer, and you're going to make sure you turn on the spectrophotometer, and it has a UV wavelength in it. So you're going to set it to 340 nanometers, and after you set it to 340 nanometers, you're going to take a cuvette. So your cuvettes are initially empty. They have nothing in them to start. And remember, we already talked about how this is the 1 centimeter path length side for the cuvette, and the light is going to go through this side of the cuvette from here over to here. So you don't want to touch the cuvette right here, but it's okay to touch the cuvette on the top of it. If you touch it here, you're going to leave fingerprints on it. So you're going to take a cuvette, and you're going to add 1 ml of your MOPS solution to start with. I'm using pH 7.5. For your part A, you're going to be using pH 7.0 to start, but we're going to pretend I'm maybe doing the pH portion here, part C, and raise the lid, and with your 1 ml of the MOPS added, along with 10 microliters of pyruvate. So 10 microliters, and you're going to put a tip on your 10 microliter pipette, and you're going to get 10 microliters of pyruvate out of your tube, and you're going to put it in here. Now, pyruvate does not absorb at 340 nanometers, so you don't need to worry too much about mixing it right now, but you definitely need at least 1 ml of MOPS in there to be able to blank the solution. So remember, you're putting the long path length that the clear side that's going to be red along the light path of the spectrophotometer. So you put it all the way down, close the lid. Initially, it's going to have some reading to it, but this is your blank. So you're going to hit measure blank right there. And you're blanking it with the buffer and the pyruvate in it before you add the NADH. Once you add the NADH, you're going to have a very positive number. Never ever blank it with the NADH already in it, because if you add the NADH where the absorbance is going to be around 1.8, and then you blank it, then you're going to be going negative basically, and the spectrophotometer cannot accurately go negative. So after you have added your pyruvate and blanked it, then you're going to add the NADH. You're going to add the NADH to your cuvette. Now, this is the important part to mix. This is one of the important parts to mix right here. Get it all mixed up. If you don't mix your solution at this point, you're going to have just a little nugget of NADH in there, and that nugget of NADH is going to be maybe floating up and down in the solution, and as it floats into view, the spectrophotometer reading is going to go high, and as it recedes, maybe goes lower, the spectrophotometer reading is going to go low, and so you're going to get a really wavering up and down reading on the spectrophotometer. So you have to make sure it's mixed in there. And then again, you're going to close the lid and get a good reading. So our initial reading in this case is 1.863. This is our time 0 reading. This is where we are starting. So at time 0 on your graph, you are at 1.863 in terms of your absorbance. So now the key is, now you are ready to add your amount of enzyme. And you're going to have your enzyme on ice. And so you're going to be taking, and the NADH does not have to be on ice. The pyruvate does not have to be on ice. They can be on ice, but they don't have to be on ice. The enzyme should be on ice if you're using it very long at all. Your MOPS should not be on ice, because if you have your 1 ml solution on ice, so that you're doing this at 4 degrees Celsius, and you add 4 degrees Celsius material into a cuvette, 2 things are going to happen. 1, the cold solution is going to cause frostiness as you get condensation on the outside of the cuvette. 2, temperature affects the rate of reaction. So if you have MOPS that's been on ice, maybe it's 4 degrees Celsius, and you're doing your reaction with a 4 degrees Celsius solution, then your rate of reaction is going to be very different. And as your MOPS maybe starts warming up, your rates of reaction are going to be all over the place. So your MOPS should never be on ice. And the NADH and pyruvate, it's up to you. The enzyme must be on ice for preservation. So you're going to put your amount of enzyme in there, get it in there. From the time you add it, you have 30 seconds to get it all mixed up and start your first reading. So one person in your group should be starting the reading and at time 0, and it can be read to the person. So you can see now we're at 1.519 and it's going down. So at 30 seconds, we'd say, okay, 1.36. And then another 30 seconds maybe passes and okay, we're at 1.0 something. So basically what you want to do is you want to get readings for 3 to 6 minutes. You want to be able to say it's going to have a certain rate for 3 to 6 minutes. At the end of that 3 or 6 minute period, wherever you have the linear range, then you're going to stop and graph it, and you're going to say, this is my absorbance, this is my time, and you're going to have a dA dt graph. So this is your basic reaction that you're going to do for all of these different parts. This is the first part with the progress curve, or you're going to be changing your pH in part C to measure the effective pH on velocity. You're going to be changing the amount of enzyme to measure the effective enzyme concentration on velocity. And you're going to be changing the amount of substrate that you have to measure the effects of pyruvate concentration on velocity. And then you're going to be adding an inhibitor in there to be able to say, here is the effect of the inhibitor. So that's your assay.